Right, so the first question here is what is the Doppler effect? So this is the increase, maybe be easier to type, the increase or decrease in the frequency of a wave due to a relative motion between the source of the wave and the observer. That's the Doppler effect. An increase or decrease in the frequency of a wave could be light or sound due to a relative motion between the source and observer. And they ask you to describe the Eiffel diagram, how the Doppler effect occurs. So I found this nice picture that we could use to demonstrate it. So you can see what's happening here. This is the source, and it's moving relative to these two observers. This guy here, he will hear a higher frequency due to the smaller wavelengths. The waves, the crests are closer together because the source and the direction of propagation of the wave are in the same direction, so the crests get pushed together, and conversely in the opposite direction here they get stretched apart, so it'll sound like a lower frequency due to the longer wavelength. So that's the type of picture I always picture in physics books when I'm picturing the Doppler effect. And then the last part here, part 3, I should have obviously have to write out the explanation here, but as you can see it's a bit hard to write long things out with my writing pad. The last part here is the calculation. So the formula for the frequency the observer hears, F0, speed of sound, and then you have V0 here, and then Vs here, and you have to think about the signs. So he's on the top, and the ball is here after 3 seconds, we'll say. So this direction is minus for the ball, this is plus, this is plus, this is minus. He's not moving, so we don't really have to worry about the plus or minus here for the observer, so it doesn't really matter because it's going to be 0 anyways. The source is moving away, so a plus there. Okay, and what I can't remember is if the F0 is the source or the observer. Let me pause and check for a second. Yeah, as I thought it was the source, but it's kind of weird. It's an O. Maybe it'd make more sense to call that an S. Anyways, it's 500, and then the speed of sound is 340, and then 340 plus the velocity of the source. We have to work that out. So that's going to be V equals U plus A t. So it's traveling at 29.4 meters per second. Okay. So that is a lower frequency due to the longer wavelengths, like in the diagram previously, because the source is moving away from Pierre. The crests of the wave are spread out, which makes it sound like a lower frequency. If there was somebody at the bottom of the tower, they would hear a higher frequency. So yeah, he must be at the top because he drops the toy. Pierre drops the toy to the top of the Eiffel Tower. Calculate the frequency after 3 seconds. Yeah, it seems reasonable to me. Okay, so Doppler effect, diagram, and a calculation. All right.